All right, today we're putting on our detective hats. We're opening a case file on one of the most compelling, unsolved mysteries in the entire universe, a visitor that came to us from another star system. It's a real cosmic whodunit.
But here's the thing, before our mystery guest even showed up, scientists were already dealing with a huge problem. This quote right here, it just nails the feeling in cosmology at the time. This growing suspicion that our basic understanding of the universe might be, well, wrong.
So, the first piece of evidence in our cosmic detective story isn't a thing, it's a crack in the rulebook. It's a fundamental problem that astronomers call the Hubble tension.
So what exactly is the Hubble tension? Well, think of it like a cosmic mismatch. When we look way back at the afterglow of the Big Bang and calculate how fast the universe should be expanding, we get one number. But when we measure the expansion using stars and galaxies closer to us right here, right now, we get a different number, a faster one. And here's the problem. Those two numbers, they're supposed to be the same. The fact that they aren't, well, it suggests our standard model of how the universe works is missing something big.
It was right into this environment of questioning and confusion that our main suspect made its grand entrance, arriving totally unannounced from the vast emptiness of interstellar space.
On October 19, 2017, astronomers using the Pan-STARRS telescope in Hawaii saw something they had never, ever seen before, the first confirmed object to visit our solar system from another star. They gave it the name ʻOumuamua. It's this beautiful Hawaiian name that just captures its essence perfectly. It means scout or first distant messenger. It's like it was sent to us from across the galaxy, a messenger from the distant past.
Now, the biggest challenge for our detectives was time. We had almost none of it. See, ʻOumuamua was discovered after it had already swung around the sun and was speeding away from us. By January of 2018, poof, it was gone. Too faint for even Hubble to see, leaving behind nothing but a trail of absolutely baffling clues.
So, what was it about this first messenger that made it so unbelievably strange? Okay, let's open the evidence file.
Clue number one, it completely broke the rules for comets. You know how comets get close to the sun, they heat up, and they blast off gas and dust, making that classic tail or coma. Well, ʻOumuamua got super close to the sun, and nothing. No coma, no tail, not a hint of one. And yet, it was accelerating, as if something was gently pushing it. And the clues just kept getting weirder and weirder. The way its brightness changed suggested a really extreme shape, maybe 10 times longer than it was wide, like a cosmic cigar or a pancake. It wasn't spinning gracefully either. It was tumbling chaotically, end over end. And its reddish color hinted that its surface had been zapped by cosmic rays for millions, maybe even billions of years.
And this number right here? This is the smoking gun. Its orbital eccentricity was 1.20. Now, in orbital mechanics, that's huge. Anything over 1.0 means an object is not trapped by the sun's gravity. It's just passing through. This was the mathematical proof. ʻOumuamua came from the stars and it was heading right back out to the stars.
Which brings us right to the central question, doesn't it? The absolute heart of the mystery. What in the universe was giving it that small but unmistakable push away from the sun if it wasn't acting like a comet?
This effect has a name, non-gravitational acceleration, and honestly, it is the most compelling clue in this entire case. For ʻOumuamua, the cause is just a complete unknown. Now, to understand how scientists even begin to tackle a mystery this strange, it really helps to look at a similar case from the past.
So to see how scientists approach a puzzle like ʻOumuamua, let's take a look at another bizarre case that popped up a few years earlier, the incredible mystery of Tabby's star. This was Tabby's star, and it was dimming in these wild, irregular ways, sometimes by a whopping 20%. One of the most exciting early theories, one that got everyone talking, was that we were seeing an alien megastructure, some massive piece of engineering built by a super advanced civilization to soak up the star's energy. But science, just like good detective work, it all comes down to the evidence. Researchers looked at the color of the light that was getting blocked. See, a solid object, like a giant alien structure or even just a beach umbrella, it would block all colors of light equally. But what they found was that blue and UV light from the star was dimming more than the red light. And that is a classic telltale sign of fine dust. So the verdict came in. It wasn't aliens. It was a massive, clumpy cloud of dust orbiting the star.
The lesson for cosmology was crystal clear. Before you jump to an extraordinary conclusion, you have to investigate every single possible natural explanation. And that is the exact playbook being used for ʻOumuamua.
So, armed with all that evidence and the hard-won lesson from Tabby's star, let's check out the lineup of suspects, the leading theories that could finally crack the case of ʻOumuamua.
Okay, here's our lineup. Could it be a nitrogen iceberg, a chunk broken off an alien Pluto, with invisible gas giving it that push? Maybe. Or what about a hydrogen iceberg that formed in deep space? A really strong new theory suggests it was a special kind of water ice comet, releasing trapped hydrogen gas that we couldn't see. And then, of course, there's the most talked about idea that it was an artificial technosignature, something like a solar sail pushed by starlight. But an extraordinary claim needs extraordinary evidence, and we just don't have it.
So after reviewing all the evidence, all the suspects, where does our cosmic investigation stand now?
Well, the hard truth is, unlike the case of Tabby's star, this one is still very much unsolved. Our mystery visitor is long gone, hurtling back into the interstellar dark, and the tiny amount of data we managed to collect means we might never, ever know for certain what it was.
And this is really why this case matters so much. ʻOumuamua, just like that Hubble tension we started with, is a loose thread. And in science, when you find a loose thread like that and you start to pull on it, sometimes the whole tapestry of your understanding can unravel, revealing a brand new, more complete picture of reality.
These puzzles aren't failures. In fact, as physicist Simon Burra says, they're exactly what scientists are hoping for. Finding a crack in our understanding is the very first step toward building something stronger, something deeper, something more profound.
And that leaves us with one final incredible thought. ʻOumuamua proved that objects from other stars are sailing right through our own backyard. So the question now is, was it a unique, once-in-a-lifetime weirdo, or was it just the first scout? The case may be cold, but for us, the watch has just begun.